So in the book, they talk about the different shapes of the universe, and this is really hard to sort of visualize. So again, we're going to use analogies, and again, the analogies will break down after a while. So remember our flat rubber sheet, the empty universe with nothing in it? Well, it turns out that it doesn't have to be an empty universe to be flat. It just has to have a certain amount of material. The density has to be just right. Essentially, what's happening is that you're balancing the expansion of the universe with the gravity of all the stuff in the universe. This is a possible overall shape for the entire universe, but on a two-dimensional level rather than a four-dimensional level, and it is called flat. Another possibility is that the universe could be curved like a sphere. Imagine the surface of the sphere. Imagine taking this and wrapping it around so you make a sphere. So this is a spherical or closed universe. You'll see why it's called closed in a couple of minutes. Another shape of the universe is sometimes called a saddle or hyperbolic or hyperboloidal. I think it looks like a Pringle potato chip. Now, unfortunately, there were no Pringles downstairs in the machine, so I had here we have a Ruffles potato chip. But you get the idea that it is curved in a different way. Imagine taking this and sort of flaring it up rather than curving it around, okay? This is also called an open universe for reasons that we'll get to in a couple of minutes. All right, so this universe has just the right amount of stuff, a balance between the expansion of the universe and the density of matter in the universe. This universe has too much stuff. That's why the universe curves in on itself. Hypothetically, if we lived in one of these universes and you had a powerful enough laser and a lot of free time on your hands, you could shine this laser into space. It would follow the curvature of the universe, come all the way back around and hit you in the back of the head. This one, the saddle or the open universe, has not enough stuff. It doesn't have enough stuff to make the universe lay flat. So that's why it sort of flares, okay? So balance, too much stuff, not enough stuff. Now, how can we measure which of these universes we actually live in? Well, one thing we could do is figure out how the laws of geometry would be different in these different universes. Now, again, I'm sorry to give you bad flashbacks. I know my high school geometry class was a little sketchy. But remember, in high school geometry, you learned a couple of important rules. You learned that if you drew a triangle, the sum of the interior angles was 180 degrees. And you learned that if two lines start parallel, they stay parallel forever. In a flat universe, those laws hold. The laws of Euclidean geometry that you learned in high school hold. I could put a triangle, a million light years on each side. And with a really huge protractor, I could figure out that the sum of those angles would still be 180 degrees, right? If we had a spherical or closed universe, you notice how I've drawn a triangle on this ball, and you see how distorted it is? So if I measure the sum of the interior angles with a protractor, it's going to be more than 180 degrees because of the curvature of this space. And these parallel lines, they started parallel, but you see how they meet? Think about lines of longitude on the Earth. You start parallel at the equator, and then they meet at the north or south poles. And then I had a hard time drawing on this potato chip, so please bear with me. You'll see that my triangle looks a little funny. The triangle is a little pinched in. So the sum of the angles is less than 180 degrees. And here I have my lines that started parallel, but because the potato chip flares out, those parallel lines flare out as well. So hypothetically, by using the difference in the laws of geometry in these three different curved spacetimes, we could experimentally figure out what universe we live in. And it's important to know what universe we live in because that's going to determine how the universe will end. So here we have a diagram, a similar diagram in the book. time. Here is the Big Bang right here. So that's the origin of the universe where time equals 0. And here's the size of the universe. If there's too much stuff, if we live in a spherical or closed universe, we start with the Big Bang, but there's too much stuff. So the gravity of all the stuff in the universe would eventually stop the expansion of the universe. The universe would collapse in on itself. Everything's red shifted now, it would be blue shifted. If you ever wake up and the galaxies are all blue shifted, it's going to be a really bad day. So what would happen in this case is that the universe would collapse in on itself. If that's the Big Bang, that's the Big Crunch, right? In the opposite case, where there's not enough stuff, where the expansion of the universe wins because there's not enough stuff in the universe to stop it, the expansion of the universe does slow down over time, but it just keeps going. And that's why we call that an open universe. But what if there's just the right amount of stuff? If there's just the right amount of stuff and we have a balance, not too much, not too little, Goldilocks, the expansion of the universe slows down. It never actually stops, but it slows down a lot more than in the open case. So, which universe do we live in? Stay tuned. The answer is actually none of the above.